Well, good morning. Thanks so much for joining me here in my shop this morning on the 3rd of December 2002. And here I am facing a radio that I thought was working really well when I started work on it. And now I think it's not working well at all. So, yikes. Am I responsible for what's happened here? Could well be that I've made some mistake and I haven't figured it out yet. Something unusual has gone wrong in the work I'm doing. That's one possibility. Another possibility is the radio actually never did work all that well and I didn't realize it when I started. And what's another possibility? Who knows what the possibility is. So that could be my focus today, is to try to track down. I'm going to have to probably inch my way through the radio at this point, starting at the antenna and just inching my way through it. I was kind of doing that a little bit with signal tracing yesterday. Maybe I could do a little signal injection testing. I don't know. I don't know how to approach it just yet, but maybe the absolutely first thing I should do is prove that it doesn't work. I mean, I think I've done this 5 times, but I still have the willy-nillys. But how about some fun stuff first? How about this capacitor? This is the RF filter capacitor, line filter capacitor, supposedly filters noises from the power line from getting into the radio and showing up in your speaker. Now when I look at this at a glance, it looks like a mica capacitor, except it's kind of big for a mica capacitor, and doesn't quite look like other mica capacitors, but it could be. I think it would be interesting to open this up and look inside. I gave this capacitor the usual test on my capacitor tester, and it showed up very leaky. Can a mica capacitor be leaky like that? I'm not sure. So I'm going to use my power crusher here. It says ice cold, just came out of my garage. I'm literally going to crush this open. I'm going to try anyway. Don't get hit by flying debris. Just keep cranking it down. It's starting to crack open here. Actually, it looks like the seal is broken on the back of it. Let's see if I can just pry it open now. This whole side's coming off. Let's put the close-up camera on it because I can't see much like this myself. Okay, let me adjust the focus a little bit. I can just pull it back. Whoop, whoop. Over the edge. I want it up close like this. Okay, let me just fix the focus here. Bear with me for a moment. Just getting a hold of the dialog box for the camera. Okay, what do we see so far? Couldn't be absolutely sure what I'm seeing in here. I see a large piece of metal right up at the top going across. Let's smash some more open. It's all cracked along here. There we go. Got the whole back off. Some kind of papery material stuck here, all the fibers. You can see all the fibers there. See if I can get the whole thing to come out now. A little more crushing. Lots of papery fiber. Get a look at it now. There we go. Okay, got the case right off of it. The capacitor itself is still intact. Looks like some aluminum foil back in here. Well, we can. And these outer pieces look like they've been bent down onto it. Now let's bend them off it. Wow, this is going to be a little heavy. Well, you can see lots of tin foil here. Whole thing can bend. Oh, pulling it off there. There we go. So what they've done, probably interleaved the tin foil in the paper. Like two things put together like your fingers going together. Kind of see what I'm doing there. And we'll see how they manufactured it. Well, this is probably a roll that's been flattened. Felt like an outer cover. Got this yellowy material. I don't think it's conductive. Well, maybe it is. Okay, so did I mention this would probably destroy the capacitor? I don't think you can use it after this kind of effort's been put onto it. Well, I'm really distorting it now. So it's almost like there's a... Yeah, I don't think it's going to work. What? There's more. Yeah, so here we are. Now we can see the actual construction. The paper and the tin woven around, and then like the ends here are kind of bunging it up. Yeah, so this is your basic paper capacitor. Except instead of being in tubular form, I'll show you on the big camera how much of this there actually is. Whoa. That's about the end of the road there. Let's flip to the other camera. How much was in that little box? as much stuff. And it's just, this feels more like cellophane. This is not paper. This is some cellophane or some kind of material like that. And then we have the tin foil. There's probably two of them. Yeah, see there's a tin foil here and a tin foil here, separated by this cellophane-like material. And this is going to be the other tin foil. And all they do is, instead of stacking it, like stacking it right up on top of itself, they have one roll of paper this way and the other roll that way. So the you can see this here. So the tin foil edge sticks out beyond the plastic. And they do the same thing on the other side with the other piece of tin foil. So they have a tin foil sticking out on either side. They fold it over, clamp it with these metal clamps. It's just clamped on there. I don't think there's anything. Oh, maybe there is something going on. Let's take a look inside this little piece here. Well, they've got this lead, which is soldered on, I think. And perhaps that's the solder from soldering the lead on. But it looks like there's some tin foil caught in there. You can't really solder to the aluminum foil. I'm calling it tin foil, but it's aluminum. You can't really solder to aluminum. That's why they have the compression connector. It's only a reliable way to make a connection to this pile of junk here now. Yeah, that capacitor, that's done. That's definitely done. Well, that was interesting. So, paper capacitor. And that's, the measurement I made on it was that it was leaky. And again, I really have my doubts over whether a mica capacitor shows a leak like that. Don't know for sure. Okay, that's done. That was fun. I think I deserve a little bit of coffee now. Coffee is my reward. Okay, hopefully the rest of this video is constructive instead of destructive. Let's find out. So I'm going right back to square one. What I've done is I've hooked up a loop antenna to the antenna terminals here, and I'm going to try to pick up some AM radio, and because it worked before. Didn't it work before? Am I confused about these radios? I've done so many radios I can get thoughts about other radios in my head when I'm working on one like this and start thinking I'm yeah, I won't go into it. Okay, so now the loop antenna should provide a pretty strong low noise signal, a very strong low noise signal to the radio, much better than a wire antenna or certainly any other antenna I've got available here. So lots of volume. Now, we will try. Let's try a tough one. We'll try around 860. So first I need to tune the antenna. I wish this bright spot wasn't here, but it is. You know what I could do about that? I could do this. Oh, I can't do this. It's going to undo the light bulb. We'll leave that aside. I'll tune my antenna over here just in case you haven't seen it. This exciting antenna I built years ago. Has no effect. I'm pretty sure it's this radio. I played AM out of it briefly. I remember determining that using the A1, A2 balanced antenna input method didn't work, so it didn't work particularly well. But hooking the loop up with the ground in place seemed to, so I'm going to change that now, in case, gaming could just be wrong, but this certainly makes it seem that there is no signal making it from the antenna into the radio, even though the radio sounds like it's picking stuff up. Okay, so I'm going to move one lead off. There's nothing happening on the radio. Like, we should hear stuff. We should hear... That was me turning the volume. We should hear, clicks and pops and stuff like that. Okay, I'm going to tune the radio again, or tune the antenna again. Keep an eye on the radio for me. Okay. Yeah, there's nothing. Nothing at all. It's as if it's not even hooked up. I mean, when I disconnect it here, nothing whatsoever. So, okay, what are the odds? What are the odds that the problem has occurred spontaneously while I've been working on the radio? Maybe something adjacent to what I've been doing gave up the ghost. I would put the chances of that very low. Very low for a couple of reasons. What are the chances that I made an error while I was doing the work? Now, I was testing the radio, but all I was doing was turning it on and hearing this and doing this. Oh yeah, it's working. Well, it's doing something, but it doesn't seem to be doing it from the antenna terminals. So probably the checks I was doing were not effective in detecting a problem in the radio. So, that would suggest to me, yeah, I could have easily put in a problem, put in one of these parts wrong, done something wrong somewhere. And that is the problem. The problem really is me. And, that's often the case in these situations. Very often the case. Well, I only replaced a few parts up in the front end of the radio. You can obviously see this one, these two, resistor there. This is the first tube in the radio. And from there, the signal travels over to this tube, where I've replaced this part. This capacitor has nothing directly to do with this, but I don't know. Now, the testing I've done suggests the tube resistances are good, the tube voltages are valid, the tube itself is operating. There seems to be no or a weak signal on the grid. No, that's not true now. I think when I used the signal tracer, I found the signal on the grid to be stronger than the signal coming into the antenna, and that's because there's a transformer. That would suggest the transformer is working. This is only true when you have the radio tuned to the signal coming in. But when I look for it on the output, it doesn't seem to be there. We need to repeat that process. So basically, trace the signal one way or another, coming right from the antenna to this tube and then out of this tube, and verify things. I think that's what I'm going to have to do. So I'm going to set things up to do that. See what happens. Listen very carefully. There's a beat in there. Is that music? Don't really hear it now. I've always found when listening to noises like this very, very carefully, I start imagining I'm hearing things. So that's probably what's happening there. So we're sending 725 kilohertz to the radio. We're tuned to 8. Let's go down to 725. Oh, there's that heterodyne problem. That's got to be part of the picture. We've gone right past 725. A fairly weak signal coming in here. Let's pound it a little bit. Okay, that's 100 times stronger signal. We're going to hear this. See that? That rumbly sound is a noise I commonly hear in my shop here on these radios. Is that coming in on the antenna? So I have a very strong signal on the back of the radio now. Any radio would hear it. Oh, the heterodyne. Is that from the signal generator? Let me take the antenna off. No, it's making no difference. Watch out there. Sticking my knuckle in the radio. In for a surprise. Okay, so now we're going to blast the signal, just a ridiculously strong signal, into this radio. There he is. If you blast enough signal, it makes it. But is it even coming through the antenna? It seemed to be the case. Now, what if I put this level of signal onto the grid of that first tube? Yeow, I think my neighbors would ask what's going on in my house. So we're going to get a capacitor. We're going to turn this way down. Start there. And we're looking for, isn't it number 3? I cannot remember for sure. So let me take a quick peek at the schematic here, just to be sure. Just bear with me a moment. Oh, I can't read that schematic. Here we are. 6SG7. Grid is pin number 4. Pin number 4, 1, 2, 4. Okay, I see it. I'm just going to touch it. We're just going to touch it here. Really? I have this on a pretty low setting now. So I'm going to clip this onto the grid line, which is just absolutely dead. Stick my fingers away in here. Okay, I survived that. So I believe I'm feeding the signal right into the grid of this tube. More signal. So this is a pretty strong signal now coming over. Let me check the calibration on my signal generator here. So that's now 1,000 microvolts on the grid. 10,000, you barely hear it. Barely hear it. Okay, so I'm going to want to put the same signal onto the grid of the next tube. Either stick it into the grid of the next tube or put it on the plate of the last tube. A little safer for my signal generator if I stick with grids. So I'm going to go to this tube. This is a 6SA7. 6SA7, the grid is grid number 1. Pin number 5. Pin number 5. Okay, so we're going to pull this off here. Grid number 5. One, 2, 3, 4, 5. Grid 5 is a little hard to get to. That would be. So I'll turn this down. Now this is still the antenna type signal, RF signal. Yeah. I don't think I can do it quite like this. Fingers are everywhere in there. Okay. You hear that? Yeah, who needs this whole front end of the radio? It's not doing anything. It's all being received by just some wires up in here. Okay, signal generator, fairly low signal. Wow, everything kind of went away. Shouldn't we be hearing that at this point? Shouldn't we hear that? Did I really get the right pin? Let's just double check that out. 1, 1, 2, 3. No, I'm not on the right pin. I'm on the wrong pin. Who knows what I hooked up to there? Wrong pin. Let's just count that again. Because what they've done with a lot of these two bases is they've taken the terminals for pin 1 and 2 and they've bent them together like this. And then if you cover that up just right, it looks like 1. And you go 1, and then you count 2. It's really 1, 2, 3. So I'm counting wrong. This one, yeah, this one's got 2 folded over, so 1, 2, 3, 4. Yeah, I was on the wrong pin. Wrong pin. Okay, let's try this now. So you see, I think I'm hooking up to a grid with no voltage. Meanwhile, I'm hooking up to the plate or something like that without realizing it. I think I'm safe when I'm not. I think my equipment's safe when it's not. Let's do that. Oh! Oh! What did I do? What did I do? What did I do? I mean, that should cause a lot. 6 SA 7. What did I do? Did I move up here? Grid 1. Yeah, pin 5, not 4. Pin 4 is hard to make out. Screens! That's a screen now. What am I doing? 1, 2, 3, 4, 5. Grid 1's on pin 5. Okay. I can't remember a number even for seconds. Pull that off. Okay, so we're going to count 5. Don't say 4 now. 5. 1, 2, 3, 4. 5 is the first one. The first one I was on. We're back to what I was. I'm looking to see if I can read the numbers right on the... Sometimes these are numbered. Right on there. 4, 5. Well, the first one was 5. That's curious. Let's go back to it now. Boy, sooner or later I'm going to get a shock off this radio, I can tell. Maybe sooner. Oh, careful, man. Fingers are going everywhere. This is no good. Too scary. Too scary. Turn off the power. Too scary. Trying to save time by gambling your life. Doesn't sound like a good deal. It's on there. It's not shorted anywhere. It's good and solid too. Okay, power back on. Now this time when I touch it, it does sound like a grid. Well, we'll see. Absolutely. So why can't we feed in a signal? Because there's no local oscillator. Okay, so we're tuned up around 8. We're feeding in 7. Let's give it more juice here. Now, tune this baby. It's nothing. Now, how could it be I heard this on how could it be I heard this when I had it on the antenna full blast, but now I can't hear it? I think I've moved it up. Well, I'm not full blast. Let's blast it. You blasted radio. That's not happy. Okay, we're going to give it everything it's got. A little something there. Some stuff happening way up here. Stuff up here. As a guess, I'd say there's no local oscillator operating in this radio. Well, we need to check that. No local oscillator. You can't generate a intermediate frequency of 455 kilohertz. It'll never come out, and so you won't hear anything. But occasionally there are other signals, noise signals and whatnot, that are going to mix with the incoming signal, and you're going to get a little bit out the speaker because they're going to happen to mix and produce the 455. That's my thinking. That's what I think I'm hearing. As I tune up and down, I hear a little bit here and there. Fake local oscillators. Other bands it does seem to work because it can tune stuff in. Okay, we need to prove the local oscillator is either there or it's not. Okay, so I'm going to do a little bit of setup for that. Okay, so I have my SDR running. Well, I'll put it on the screen in a moment. This is the antenna. So I'm just making sure I've done this correctly. Yep. This is my SDR radio sitting right here. That little box. This pickup coil on most radios, the local oscillator I found is easily picked up some distance from the radio. So we just need to put this anywhere near the local oscillator circuits, which I'm going to guess are these here. So I'm just going to stick this in here. Try not to let it short onto anything. You know, we don't need this. We don't need this here. We don't need this here. Ooh, flying clip lead. Okay, put that off. Put this guy. Okay, hang it right on this. Perfect. Okay, so if there's a local oscillator, we should be able to see it on my SDR. So let's take a look at that now. Oh, well, there it is right there. I'll tune the radio a little bit. What is going on? So let's set this to 1 million. So it's tuning 455 below a million now. That's going to be 545. So if I look at the dial, wait a minute, no. What am I saying? 6. Can't do arithmetic in the morning. Can't do it in the evening either. 455. I think it's 555. Oh my God. Okay. I'm going to get a calculator out here and do this. We have the local oscillator at 1 million. Okay, let's just do it like this. 1 million, and below it by 455. Shoot. Calculator's not helping me much. Let's try that again. Million minus 455. It's 545. Okay, so we think we're listening to a signal at 545. 530 is the bottom of the scale. Like 545 would be just into it. And on the dial, well, the dial says 650. What am I doing here? This is way off. This local oscillator is way off. Well, let's move the local oscillator to 1,455,000. That's where the arithmetic gets easy. 455, right here. Okay, so I'm going to tune the radio, send that guy way up there. Now the radio should be receiving a signal at 1 million. Okay, so we know where that's going on. Sort of chosen wrong words. We know what's going on there. So now we're going to feed in the 1 million. I'm at square one still here. We don't need this in here anymore. Put this on the ground. I have the ground link closed. Okay. Now if I dial in 1 million over here, we should hear it. Can't get to 1 million from here. Gotta go up to here. Oop, that's not gonna work. Gotta go here. 1 million. This is a sort of an average signal. 1 million. Now, I know the IF is running at 455, and I know the local oscillator is at 1.455. So this signal should be audible. Oh, it's just barely there. Can't even hear the modulation on it. That's a very strong signal. Here's a stupidly strong signal. Ooh, 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 some otherworldly sound coming out of there. Okay, well, I've really proven there's something wrong. There's definitely something wrong here, Jeff. Cannot question that anymore. Now, I should be able to feed this signal into the mixer tube. Maybe the mixer tube went south. And that's why we're not getting anything here. How warm is that tube? Oh! Ooh, yeah, it's warm. All right. Well, I've done a couple of capacitors. I've really only done this one here. So if the local oscillator is going and I jam a 1 million signal into the grid of the 6SA7, it's got to come out. The grid was pin number 5. How can I double check that? I got another. I have updated. The book can't be wrong. Here's another one anyway. Just because I'm reaching. I'm reaching so hard now. 6SA. Maybe the book's wrong. 6SA7. Oh, it's going to put it in this chart, is it? 6S. Where are you? SA7. Refer to chart at end of section. Oh, for crying out loud! There's nothing handy about that. Yeah, I'm blowing smoke anyway. Stop that. Stop that nonsense. We will look in my favorite book here. 6SA7. Just you know, in case. I have to like triple or quadruple check everything. 6SA7, grid. So grid 3 is what we're after. Grid 3 is pin 8. What am I doing? I'm on the low. Oh. No wonder there's no local oscillator. I think I put my signal generator onto the grid that's carrying the oscillator. Stupidly. Very stupidly. Grid 8 is the one we want to get on. Okay. Did I say something about making mistakes while you're doing this? Grid 8. I'm going to take it off here. I'm going to look for grid 8 on this tube. That's real easy to find. I'm going to touch it for a noise check. Finger it. Okay, that would sound like a grid, sort of. I'm going to put on a capacitor. This one's really easy to do. Put on the signal generator. Just want to turn the level down. So I don't think I tuned the radio again, did I? Did I? I don't think I did. So the local oscillator should still be at a million 455. This should be tuned to a million. There's a million coming from there right now, but maybe it's not exactly. Oop. Oh, we're cooking with gas now. A lot. That's a pretty strong signal. That's what it takes to get through this tube, is a really strong signal. A lot of radios, the antenna is essentially connected right to this pin here that I'm on. There's no first tube. And that's enough to operate the radio. Wouldn't it be the same here? Sure, it would be the same. So why so much signal needed? Okay, what we'll do now is we're going to move this back to the antenna. I'm going to take this capacitor off. There is a capacitor in the lead of my signal generator in this little blue box here. Just so you know. Okay, that's a phenomenally strong signal. That'd be like super station. You live next door to an AM station and you have a wire going over right near the antenna. To get something this strong. Yeah, I don't hear anything. Let's not turn that. Let's turn this. Nobody's home. Oh, there's a little wee bit there of something. You should trace through it with the signal tracer now. Again. And just follow the signal step by step and see where it's disappearing. I think it's going pretty early on in the scheme of things here. So let's do that next. Okay, I think we're all set here. You're listening to this guy here. I'm going to tune him right around a million. That's the signal that's coming from the signal generator at a pretty high level. Should be able to hear it. There it is. Just getting close to the wire. Okay, and then we're going to put it right on the incoming. Do it back here. Okay, now we're going to turn this up. Now this signal tracer has a magic eye to help with quantitative measurements. So what I'm going to advance this until the eye closes. Oops. Come on, stay on there. Okay, so if I meet up with the same signal level, the eye is going to close. The volume is independent here. I can turn it up and down all I like. The eye should not be affected by it. Okay, so the first stop on our hit parade here is to follow the green wire. Follow the green wire. Try to follow the green wire. Oh, this is going to be a... There it is. It goes up. It goes up. It goes up. Connects to the switch. Tell me it's the switch. Okay, so it connects to the back of the switch up here. So I'm going to guess this. I'm guessing. Let's just poke around and see if we can find that strong signal somewhere. It's not there. The thing is, it connects to the switch wafer in the back of the radio, like deep down inside. And I can't really... Oh my gosh, you know what's connected there? Son of a gun, that wax capacitor. No, take that back. I take that back. Could be this yellow wire. Could be this yellow wire right here. Anybody? Somebody? So this is terminal's grounded now because the link is in back here. That's what we're looking for. Green wire goes back, goes in the switch. Yeah, how many options are there coming out of that switch? Okay, there's a resistor heading down here. It's heading here. This is the grid. About the same, slightly louder, I think. So I'm going to look at the magic eye now. We'll say... closing more. Okay, so it's working great to the grid of this tube. I've already done this. I've already proven this. Now we want to find it coming out of that tube. And 6SG7. G, K, A, B, C, D, E, F, G. 6SG7. Okay, this shows the grid, which I just checked, on 4, and the plate on 8. The plate is on 8. Gotta listen to the plate. Come along, little plate. Plate on 8. So if that's 4, 5, 6, 7, 8. That's the one I thought was 8 before. So this should be a blaster. Put my hand on the volume here. It's a little unexpected. I hit the plate and it goes silent. There's a big spark there. I don't like that. I don't like that. Why a big spark? Stick the spare wire in here instead. Well, I don't hear anything at all coming out. Go back on the grid here. Pretty weak, that capacitor. How come it got so weak? Did I turn something down? I turned down the volume over here. Okay. Hear it? Hear it? And then hear it on the grid? Sure. Hear it on the plate? No siree. Now, isn't that for sure the plate connection for what happened here? The radio sounds different suddenly. Oh. It's because I'm getting confused. I'm hearing this guy. I'm hearing my signal tracer. Let's take the antenna off here. Okay, back to the radio. Am I just confused about which pin is which? So as I sort of said, almost these things are often numbered. See, I have my left hand restraining my right hand, so my right hand won't get carried away. Well, I see numbers, but they're very hard to make out. There's a 5. There's a 6. 7, there would be 8. There's nothing coming out of this tube again. Now I tested that tube. The tube tested good. I've tested the resistances on the pins. The resistances test good. I've checked the voltages. The voltages are good. The problem is right there. That tube is just producing nothing. What is going on? What is going on? I gotta get another 6SG7 and stick it in there. That's what I gotta do next. Okay, here's what I've got. This came out of my garbage can. This is the one out of the radio. This one tested bad. It was in my garbage can. I actually fished it out. This one's out of my stock. It's a pretty dirty looking thing. Not, it should operate, but whether it's good or not, I don't like really in good shape. I don't know. The one in the radio, I tested twice now. How can this be the case? So this is the only one. If the one in the radio is not working and this one is dead also, this is my only hope. My only hope. So I'm going to put this in the tester. I put them all in the tester again because maybe I made a mistake. Maybe this one's good. Maybe I got them all mixed up. I never get mixed up. That never happens. I'm going to get mixed up right here. Okay, I'll get the tube tester ready to go. Okay, tube tester is still set up for this kind of tube. Now, first one we're going to test, I double checked all this already, is the one out of the radio that I rejected. We're going to see what the tube tester says about it. Two tests on this tube. It's a single tube inside, but there's two of the pins are connected to the cathode. So this thing will test either one by flipping this K1, K2 switch. But it's the same tube inside being tested. Okay, let's check out for shorts. No. This guy, if he's good, should come up 1380 like there. Well, that's pretty obviously a dead tube. That's a dead tube. It's warming up a little bit. She's as dead as can be. Okay, so we placed the dead tube way over there. Now, next one is out of my collection. This one will have had a preliminary test. Preliminary in the sense that I've proven the heater is good and it conducts. But how good it is, I paid little attention. This is the time to pay attention, just before you go to use it. Okay. Anybody shorted out in there? Nobody's shorted. There we go. Okay, so this one is testing good. Quite good. It's still going up. So I have an alternative. I'm surprised I don't have a lot of these tubes, you know. Maybe I do and I haven't really put them in my collection properly. Now I'm going to take the one out that is in the radio. This one here. 6SG7. I'm going to mix up. This is the one I just tested. 6SG. See, the G is funny on this tube. Okay, with a funny G, but how will it test? No shorts. If the tube is actually like a 6SQ7, probably the short would have come to life. Here we go. How are you looking? It's still warming up. It's as good as the other one. Better. K2. I didn't do that on that other one. I did not do the K2 thing. Okay, going now. Now I'm going to really get confused. This one is in the radio. This is the one I rejected. I'm going to test it again only with the K2 switch thrown. One of the things that can go wrong with the tube is the lead from the pin up into the tube can fail in some way. It can fail inside the tube, but more likely it fails right in the pin where it's gone inside the pin and been soldered. That can come off. Shorts. No, she remains a dead tube. Not too surprising. And is there any reason? Yes, there is. I'm going to put this as the alternative now. Put in here, I'm going to do the K2 test on it. Right there, is there anything happening? So it's just warming up still. There it is. Well, I'm going to put this alternate tube in the radio. That's what I got to do. I've put the alternate tube in, but just before I turn this guy on, I'm just going to do a crude check of these capacitors that I put in. Oh! That's 130 ohms. This is the ground point. I think that's the right amount. I think that's the right value. This one here. Basically doing that resistance test. This one, oh, come on, there you go. I'm losing my patience here. So this is 12K, and this one is all of, it was 130. It was 130. 12K and 130. Where's my book? What did I do with the book? Okay, I'm going to stop and just find the book. Okay, so the measured resistances match the table closely. So no problem with those capacitors, I would say. No problem that I'm aware of at this point. Okay, we're going to turn the guy on, and with a different tube in there. Now we have a different tube. Just make sure it's all the way down. Here we go. Different tube. What do? Is it possible I could test a tube good on my tube tester, but have it not work virtually at all in the radio? Fat chance on that. That's what I would say. Fat chance. I think we're going to get exactly the same result here. Okay, so haven't changed the band, haven't really done anything in terms of tuning. I have the signal coming in. I hear the weirdness. I hear the weirdness. It's a very, very strong signal on the antenna. It sounds exactly the same. How many tunes? Yep. Okay, so it's exactly the same. Doesn't work. Well, what can happen between the grid and the plate? Can I have trouble on the screen and trouble on the plate circuit. Beyond the plate circuit. We gotta look at the schematic at this point. We must look at the schematic. Okay, so here we are. So, nice signal here. Nothing coming out here. Nothing showing up. But the B plus is there. B plus tells us that this circuit is complete, wherever it's going out of the switch here. No reason to chase it any further. So to get, so what could kill it here? Some problem on the screen. Some problem on the cathode. A problem on the cathode. This shows a 0.05 jumping to 120 ohms. This is the one of the capacitors I just tested. And everything seems fine. If this were open circuited, well, we wouldn't get the resistance measurement. I mean, that's the end of that through here. This is set in a position that's over here. There's a ground sitting right on here, maybe a couple ohms in here. So that has to be fine. The cathode circuit has to be fine. Now, what if this wasn't there, or if it was, maybe I put a 0.1 in? I didn't, but maybe I did. No, that's not gonna hurt. So what can hurt? If they were only left with the screen. So the screen voltage is there. Now, what if this guy, I've put in a 0.1 here? Again, I can't imagine how this would hurt. I didn't though, I put a 0.05 in. If this were open, we'd have no voltage here and the resistance reading would be wrong. I'm reading 12, which is the 10. Well, that's a 1000. Where do you get 12 from? Oh, it's on this wire. Okay, so we'll follow that wire all the way. Oh, it's this one in here. And you get it from here. 1000 plus this, and that's another 12 here to ground. So shouldn't you really get 22 plus? No, you don't. You're bypassing this. You're getting this. This is all you're getting. You're getting this 12 plus the 1000, and that's what I'm seeing. I'm seeing roughly that amount there. So how does this happen then? How is it? Well, what else can be going on here? There's no signal apparent here. You should certainly hear it here. But we don't. Wow. Okay, this is really quite a mystery. Switches are messed up. Well, if the switch wasn't making contact, we'd have no B plus here. Well, what happens if I feed a signal into here? With the set off, we should be able to feed a signal in here with the set turned off and pick it up all the way over here on 8. Now, we should be able to do it with the set on also, but why gamble a bit? But that doesn't explain why there's nothing coming out here. Why is there nothing coming out here? Oh my gosh. Let me measure the screen and plate voltages again. Then we'll look at this feed a signal in here and see if it doesn't make it out over here. But it just seemed to be getting too far on. Like I'm passing the exit on the highway here, studying a map, that part of the map I shouldn't really be studying. Get back to where I'm supposed to be. A strong signal here. The signal's here, but it's not getting into the tube because there's a cold solder joint right here. That's a fat chance on that. That's a real fat chance. That connection is original. I didn't do anything with it. I did not do anything with it. What if the 27 ohms is 270 now? If it's gone up? No, that's not going to do it either. Okay, I'm gonna check these two voltages, and then we're gonna try to pass a signal through this part of the circuit for some reason. We will try that because I don't know what else really to try at this point other than drinking more coffee. I mean, there has to come a point where the coffee thing is counterproductive. It has to be. Okay, first we're gonna check voltages. Check voltages again. Once again. Maybe, you know, when you're doing this kind of work, and lots of things are like this, you're proceeding through something and you make an error on the way through it, you can carry on for quite a ways and never ever prompt yourself to go back and find that earlier thing that you booped up. I'm talking about me. I'm not really talking about you. Me. Okay. First of all, plate voltage. And we are expecting like 250, something in that range. Here we are, 260 big volts there. Screen, it's exactly right. It's supposed to be 100 volts. Okay, carry on with the next test. It's like going to the doctor. Say, doctor, I'm sick. Look at me. No, you're not sick. Everything's fine. I've done all the tests. You're just fine. But I feel sick. Oh, it's just your imagination. Well, I've certainly eliminated the "oh, it's my imagination" problem here. It's not my imagination. This radio's not working. Power it off. We'll take the signal coming in the signal generator, and we are going to put it on the plate. You know, I'm going to stop for a minute, give the radio a chance to relax. Me too. And I am going to go and try the coffee thing. Okay, that's the output of the signal generator. That's my signal tracer. That's what we hear. I'm going to close the eye here. Okay, it's taken all it's got. What happened there? Well, what just happened? Okay, not quite close, but close. That's the setting. Just turn the volume down. Now we're going to put this on the. The set is turned off. I even pulled the plug out down here. So right on that. Turn this back up a little bit. How come it's weaker? Okay. Now the eye's not closing at all. So just putting that on there has caused a problem. Now, I shouldn't say a problem. Let's just say that some of the signal's draining at this point. So that's what we got now. The eye is, I don't know, 20% closing. So now we'll come over to the grid on this tube. And which one was the grid on that tube? Better not rely on my memory. 6SA7. Yeah, you don't have any memory worth relying on. 6SA7. 6SA7, the input grid for the radio signal is number 5. G1. Pin 5. 1, pin 5, and we count 1, 2, 3, 4, 5. This is pin 5. Where'd it go? Okay, so the radio may not be tuned quite right. Up on there. It's not making any difference. So this is an interesting observation to me. And 1. Should just be straight through a set of coils. Tuning it is really necessary. Am I wrong? Is it anywhere else on this tube? It's just nowhere. Something in the plate circuit? Not right. But still we get the right resistance reading and the right voltage. And the tube's definitely good. Tube's not a factor. Somehow. Okay, so I'm going to leave it right there today. That's the end of the show for today. Tomorrow I'll just carry on here, but wow, this is I don't have anything in my bucket of ideas right now. Okay, that's great. That's a perfect way to go. This is the fun part. I just keep telling myself that. This is the fun part, Jim. Okay, well, thanks a lot for watching. And tomorrow I'll just keep pounding away on this thing.